Welcome back. Let's learn how to determine if a number is a solution to an equation. Alright, so in math, an equation is a way to state that two expressions are equal, or in other words, that two different calculations would produce the same result. And so these expressions that you could see in an equation can either be entirely made up of known numbers, which is probably what you've seen before up to this point, but equations can also include variable expressions. Alright, so here I have a couple examples of some equations. This first one here is entirely made up of constants. We have 8 plus 4 is equal to 12, which is stating that if you add 8 and 4, it should be equal to 12, and it is. Alright, we know that 8 plus 4 is 12, okay? But more often, what you will work with in algebra is what you see in the second equation here, an equation that involves a variable expression. Right, we have 3x minus 4 equals 14. And then over here, I have one more example. This is a simpler equation, which just says that y is equal to 7. Okay, so those are just some examples of equations. But in the case of equations involving variable expressions, they are not always true based on the value used for the variable. All right, so in the case over here, 8 plus 4 is equal to 12. That is always true. All right, nothing in this equation will ever make it false. Or in other words, 8 plus 4 will never equal anything other than 12. That will always be the case. But with these two equations, 3x minus 4 equals 14 and y equals 7, depending on what value you say that x or y is equal to, these equations could be false. They could make statements that are not true. Alright, remember, variables represent unknown or changing values, so depending what values you assign to those variables can affect whether an equation is true or not. And so for example, consider this equation. We have x plus 3 equals 10. If we were to say that for this equation that the value of x is 7, here's what the equation looks like. If we replace that x with 7, we get 7 plus 3 equals 10. All right, I just replaced this x with 7. And then if you simplify this, 7 plus 3 is 10, so you do get 10 equals 10. That is a true statement. 10 is equal to 10, and so we would say that the equation is true. But if we were to say that x is equal to some other number, let's say that x is equal to 5, we would have 5 plus 3 equals 10, right? We replaced x with 5. If x is equal to 5, look what happens to the equation. 5 plus 3 is 8, so you have 8 equals 10, but that's not true, right? The equal sign for an equation is saying that one thing is equal to the other, or what's on one side of the equal sign is equal to what's on the other side, but that's not true in this case. 8 is not the same as 10. So we would say that this equation is not true, all right? Or in other words, 8 is not equal to 10. And we signify that by drawing a slash through the middle of our equal sign. And now we have the symbol that represents that 8 does not equal 10. Okay, so when x equals 7, the equation was true, but when x equals 5, the equation was false. And so when we substitute a number in for a variable in an equation, and the result is an equation that is true, we call that number a solution to the equation. But if the number makes the equation false, then that number is not a solution to the equation. All right, so in our case here, 7 is a solution to this equation because it resulted in a true statement, but 5 is not a solution to this equation because it makes the equation false. Or at least it was false before we changed the equal sign to a does not equal sign. But anyway, when we're talking about the solution to an equation, what we're referring to is a number that when plugged in for a variable makes that equation true. Okay? And so for any equation that we are given, we can check to see if a number is a solution by plugging it in or substituting it in for the variable in that equation and see if the result is a true equation or not. And so that's how we can determine whether a given number is a solution to an equation. And so let's take a look at a few more examples that involve some more complicated equations. First up, we have this example. Is 6 a solution of the equation? and our equation is 3x minus 4 equals 14. This is one of the equations that we looked at the very beginning of the lesson. It was one of my examples of what an equation looks like when a variable expression is involved. And so if we want to determine if the number 6 is a solution to this equation, what we want to do is plug it in for the variable of x. Okay, and so I'm going to do that here. And something that I recommend that you do when you first start working with equations and checking solutions to help you compare the two sides of the equation that you're trying to see are the same thing, it can be helpful to draw a line straight down from the equal sign so that you can clearly see the two sides of the equation and compare their values. Okay, so in this case, if we plug in 6 or substitute 6 in for x, we get 3 times 6 minus 4 on one side and then 14 on the other. Okay, so we're comparing these two values that are on either side of the equal sign. But now what we want to do is simplify what we have over here. 14 doesn't need to be simplified, but over here we can do some math. This is very similar to how we evaluated variable expressions earlier in algebra, and it's important to remember your order of operations. In this case, we have multiplication and subtraction. You want to do the multiplication first, and 3 times 6 is 18. So we have 18 minus 4, and on the other side we still have 14. Now 18 minus 4 is 14, so we have 14 and 14, and so now, comparing what we have on either side of the equation, the number is exactly the same. What we get here is that 14 is equal to 14. That checks out. That is a true statement. So because we got a true statement when plugging 6 into the equation, we now know that 6 is a solution to the equation. All right, so the final answer here would be yes, 6 is a solution. Let's take a look at another example. Hey there, real quick, before we get to the next part of this lesson, if you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's get back to the lesson. Next up, we want to know if -2 is a solution of this equation, y squared plus 8y minus 1 equals 13. And so while the equation is different than our previous example, the process remains the same. There's one variable in this equation, that being y, so for each of those y's, we're going to plug in -2, simplify, and then see if both sides of the equation are the same value. All right, so below the equal sign, I'm going to draw a little divider here so we can easily compare the two sides. Plugging in -2, we have -2 squared plus 8 times -2 minus 1, and on the other side we still have 13. Now simplifying, -2 squared is 4, so we have 4 plus 8 times -2. 8 times -2 is -16, so we have plus -16 and then minus 1, and we still have 13 on the other side. Now simplifying further, 4 plus -16 is -12, and then -12 minus 1 is -13. All right, so we have -12 minus 1, which gives us -13, and on the other side, we still have 13. And now both sides are completely simplified, so we want to compare the results. On the left side, we have -13, but on the right side, we have +13. And so while they look very similar, the sign is not the same. This one's negative, this one is positive, so they are completely different results. What we find here is that -13 is not equal to 13, right? This is not a true statement. -13 would not be equal to 13, and so what we've shown here is that -2 is not a solution to this equation. We plugged in -2 for each of the y's, and we did not get 13 is equal to 13. We found negative 13, which is a different value. All right, so negative 2 is not a solution. That is the answer to this example. For our next example, we want to know if 3 is a solution to this equation, z squared plus 1 equals 4 plus 3z. All right, now for this equation, notice that both sides involve the variable of z. So there is going to be a little bit more work involved here. We're not just comparing a variable expression to some constant value. We are going to have to simplify both sides and see if they give the same result if z is equal to 3, right? We're going to check to see if 3 is a solution of this equation, so you want to replace all the variables of z with 3. All right, so to help us compare both sides, I'm going to locate the equal sign and then draw a divider so we can clearly see both sides of the equation. And now let's plug in 3. We'll have 3 squared plus 1, and then 4 plus 3 times 3. All right, now simplifying, 3 squared is the same as 3 times 3, which is 9. So we have 9 plus 1. And then over here, we also have 3 times 3, which is still 9. So we have 4 plus 9. 9 plus 1 is 10. So I'll write down 10. And then 4 plus 9 is 13. So we have now fully simplified both sides of the equation. And look at our results. Comparing them, they're not the same, are they? We have 10 and 13. So the final statement of the equation here would be 10 equals 13, but that's not true, right? That's an untrue statement. So really we would write 10 is not equal to 13. This does not check out. The equation is false when z is equal to 3, and so we would say here that 3 is not a solution to the equation. Okay, that is the answer to this example. We plugged in 3 and we got an untrue statement for the equation, so we know that 3 is not a solution. Okay, let's take a look at one more example for this video. All right, so for our last example, we're going to check if the fraction of 3/4 is a solution to this equation. All right, so solutions to equations don't have to be whole numbers. They can be fractions or values that include decimals. And so let's check to see if this particular equation is true when the variable of x in this case is 3/4. All right, so we're going to plug in or substitute in 3/4 for this x and this x. Okay, now before we do that, make sure to locate your equal sign. And if it helps you compare the two sides of the equation, you can draw a divider like this. And now let's work on checking if we have a solution here or not. So we'll plug in 3/4. So we have 8 times 3/4 minus 1, and then 12 times 3/4 minus 4. All right, now simplifying, remember that when you multiply a whole number by a fraction, you multiply the whole number into the numerator or the top of the fraction. So in this case, 8 times 3 is 24. So we have 24/4 minus 1. And then doing the same thing over here, 12 times 3 is 36. So we get 36 divided by 4 minus 4. Then simplifying these fractions, 24 divided by 4 is 6. So we have 6 minus 1, and then 36 divided by 4 is 9. So we have 9 minus 4. All right, and then finally, 6 minus 1 we know is 5, and 9 minus 4 is also 5. And so what we get here is a true statement, right? After plugging in 3/4 in for x in this equation and simplifying both sides of the equation, we find that both sides are equal to 5. And so we get the statement that 5 is equal to 5, which is a true statement. That checks out. So what we found here is that yes, 3/4 is a solution. Okay, that is the answer to this problem. We found that when x is equal to 3/4, both sides of the equation produce the same value. So the equation is true when using 3/4. Okay, so we're done with this example, and this was also the last example for this video. But if you do want to get some more practice determining if numbers are the solution to an equation, feel free to check out my examples video for this topic that I'll have linked here on the screen. If you have any questions, please let me know in the comments, but if you don't have any questions, this is all I had for now, so I will see you next time.